The next speaker is Elisabete Martins from Porto, in Portugal. She's going to talk to us about association with MAP infection and udder health and production.
Good morning, Mr. Chairman. Thank you for the opportunity to be here, and thank you all for being here, especially the Portuguese companions after a hard night. But I'll try and talk to you about... There's nothing in the monitor, is that okay?
It's not okay?
No, okay now.
Starting now.
So I will talk to you about some of our findings in Portugal, because we are one of those countries who are starting to do something voluntarily about MAP infection. So I will speak to you about the assessment of the potential effects of MAP in 300 milk equivalent production and somatic cell counts. And now, we don't know much, almost nothing about national prevalence. We have no PTB official control program, and we have a total absence of economical or effect measures. So, when we started this work, we were able to gather the information gathered in a voluntary control program, and now you can see in a poster presentation that we have found out at least a 58% proportion of positive herds in Portugal enrolled in the national dairy control system. As to our goals, as I said, we will see the impact on milk production and somatic cell counts. And we collected data from about 329 farms, about 20,000 cows, and which meant about 25,000 ELISA tests. Then we gathered the information from the national dairy record systems of about 15,000 cows that were those that we had tested, about 47,000 lactations, and about 4,000 milk day test results. Based on this, and I call your attention that all cows aged over 13 months old in the farms were tested, and based on the ELISA results, cows were tested in positive, negative, or dubious, as were the farms. We also had a more complex classification based on the cow farm status, but we won't discuss this today because we won't have time. Then we merged the data into Access, and we used farm ID, animal ID, and lactation number as primary keys, and then created reports for statistical analysis with SPSS and the Supermix version. Of course, our data suffered some work. We had to take out the outliners for obvious reasons, and then we have for the hierarchical models, we have to remove lactations above fifth, because we wouldn't have a sufficient number of animals for each level, and we disconsidered disregarded farms with less than 20 cows observed. As to the models, don't get scared. Now even I can say something about this. So we used a hierarchical structure, and we can... Wait, sorry. So this is the pointer. We consider lactation within animal and animals within farms. So these were our 3 levels. We considered the outcome of interest, our milk production or somatic cell count measured as a natural logarithm. We use a lactation number, cow status, farm status as predictive values, and with binary outcomes. And then we use a quadratic term of the lactation just to give you the shape of the curve of the productive life for the cow. Of course, whenever there was a significant interaction, we included that in the model, and models were compared based on the likelihood ratio tests. We will show you some descriptive results. We won't be able to talk about everything, so we selected only using all herds results and using the just positive herd results. So now we know that in our cows we have a 4.5% positive animals in our farms, and we have 29% positive cows, and it means that they have at least two positive animals. We won't consider the ones that have dubious or positive animals. As if you consider that we have almost 50% of non-negative farms, and what most considers us is that we have only 17% of the cows in potentially map-free farms. Now, what we found out when analyzing all of the farms, and I will take some more time explaining this graph to you, is that when we were modeling the effect of being a positive cow in all the farms, and you can see here we have milk production in liters, and we have lactation number. And this is not the lactation curve, this is the productive life curve. So we found the point estimates for first lactation, for second lactation, for third lactation, and so on until the fifth. And what we found is that the first parity cows, the positive ones, have higher production than the negative cows. But then, if you see here, down here, we have the cumulative difference, and at the end of the fifth lactation, the negative cows have a decrease of almost 1,200 kilos of milk. So positive cows are producing increasingly less milk than the non-positive cows as the lactation increases. As to somatic cell counts, you have here about the cutoff of about 250,000 somatic cell counts. We also find that there is an interaction, again, I forgot to mention, there is an interaction between the cow map status and the lactation number, and that's why you see the curves are not parallel. So this means that our somatic cell counts are higher in positive animals, as we already know or suspected. We have some different results in literature, but they are increasingly higher for positive cows than the increase in the non-positive cows. Still using all farms, but now observing what's happening when the farm was positive on milk production, what we found is, again, I'm right, that again, milk production was higher in positive farms than it was in non-positive farms, or in negative farms, if you want to. This is not a surprise, although it's not what we always have seen in published studies, but in fact, the cumulative difference is that about 1,250 for the positive farms above. Although we see this, we also investigated the analysis with just the negative cows, and there we find out that the negative cows from positive farms produced more milk than the negative cows from the negative farms. So this means that the positive farms, all the animals are producing more, the negative ones and the positive ones, okay? For the same analysis and somatic cell counts, we find the same thing. Somatic cell counts were higher in positive farms than in the non-positive farms, and this again increased with the lactation number. But we also found, although I'm not showing the model here, that the positive lactations in positive farms had the highest somatic cell counts of all. Now, when we took just the positive farms and look at them to see what's happening related to cow map status on milk production, what we found was quite interesting, because again, we have, for the positive farms only, first lactation positive animals have increased production, but after the second lactation, they decrease very much, and again, we observe a significant and high loss of production for those positive cows. So first and second positive lactations with higher production than the corresponding negative lactations, but at the end, at the final productive life, if you want to say, the production is significantly. Now, when modeling the effect of cow status on somatic cell count, again, we observed that even in positive farms only, the positive cows have increasingly higher somatic cell counts than the negative cows. And this, again, as a lactation number increases. But in the negative cows only analysis, which model I am not showing you here, the negative cows in positive farms had higher somatic cell counts than the negative cows in the negative farms. I'm sorry, I know this is difficult to follow. So, what can we say? We are starting, we need to show something in Portugal to our producers in order to convince them that it's their responsibility as is ours to do something, especially after our keynote speaker impressed us so much with the risks that we are. But we also know that latent animals might not have long-term production losses. And we also know that the latent infection might be a potent effect confounder or modifier. And it's not only for us, it's essentially for the producer, because positive cows tend to produce more milk. Our model, however, did not account for the progression of infection. We consider low-path animals and high-path animals as the same. We consider that once the cow was tested positive, as we didn't have the ODs or the high positive, low positive of the ELISA tests, we consider that the cow, once positive, would be assumed to be positive for all the lactations and for all her life. And as we have observed in literature, the models used to investigate these effects have accounted or not accounted for many of these major confounders, as lactation number, as farm interactions with cow status and the number of the lactation. But however, even that we didn't account for this in our model, the multi-level structure that we used and the inclusion of the significant interactions of cow farm status in the models apparently controlled for this confounding due to the stage of infection and to production threats. So, what we now know in Portugal is that Portuguese MAP cows, as in accordance to recent findings, they have more milk in first lactations and they have less milk from their own. And the cumulative difference of their productive life is very, very significant. So the same is happening with somatic cell counts, only in here you can see the effect already on first lactations. The positive farms and the positive cow results also supports the hypothesis of a positive correlation between the genetic merit or the genetic traits and the management of these most productive farms for milk production and for MAP susceptibility, as we have been suspecting for a while, and as it has been described by some authors, this possible correlation, as we see, for example, with mastitis. Of course, here we know that if production increases, the risk of mastitis will also increase, and the risk of somatic cell counts will also increase. So we are not quite sure if this increase in somatic cell counts is directly attributable to MAP, or if it's driven by the increased productive ability. And that's probably something that we might investigate. We also don't know nothing about, have I crossed the time? Oh, it hasn't turned yellow. Oh, there. Great. In conclusion, there are important impacts, and what I must say is that the multi-level hierarchical study design had excellent likelihood ratios. It also fitted the results, and their inclusion could explain this significant variability in results that has been observed in other studies. And it probably should be accounted in further analysis. I'm so sorry. Thank you all for your attention.
Thank you very much. I'm afraid we probably don't have any time for questions if we're going to stick to schedule.
Okay, thank you.
Sorry about that, Elizabeth.
No problem. I'm sorry, I didn't saw it.